everyone, my name is Andrea and today I'm presenting you the 2281S-20-6 DC precision power supply from Keithley. So 2281S-20-6. 20 stands for the maximum voltage, 6 for the maximum current, so if you do the math, it's a 120 watt power supply, no compromise. And it's actually a DC precision power supply. What does it mean, precision? Well, it means that it's very stable, it has a very low ripple, very low noise. In fact, you can notice it operates in linear mode. It's quite heavy power supplies, about 10 kilograms. And as the high performance power supplies, it also has some special functionalities. For instance, it has a high measurement resolution, 6.5 digits, so you can precisely measure the current, for instance, over a wide range of load current. And you can perform very fast current measurements. This is a power supply that can respond quite quickly to load changes in current, right? It also has other features like the battery test mode or the battery simulator mode, which we'll see in detail. In fact, this power supply can charge and discharge a battery. It can perform a battery capacity test. And during this process of charging and discharging, it can log the data, so you can actually get a model of the battery. And this model that you got from your results, or that you probably obtain in a different way, like using a source measure unit, for instance, you can load it in this unit so that it emulates the battery. And you can test the circuit that you are designing using this instead of the real battery, which is very useful. Since when you log, this device can measure the open circuit voltage and the resistance, it can also emulate this against your circuit. Let's start looking at it, how it looks like, how it appears. It has a 4.3 LCD TFT color display, not touch. You have these soft keys over here that you can use to access the menus. The front panel is quite rich and simple to use. On the rear side you have multiple interesting things. For instance, you have a digital I/O port which you can use for triggering the unit, for instance, as well. And you have the output terminals for connecting the sense inputs and the source outputs. But you can use this on a rack for an automated control measurement. And of course it's LXI compliant, so you have an Ethernet port and you have an USB port. On the front side you have two useful LIDs. One tells you if the network, the LAN, is connected, and the other one warns you about the unit being remotely controlled. In fact, we will see there is also a software companion with this power supply, which is Kickstart. The form factor is very compact. It's a 2U, so half rack. You have a USB port also on the front to retrieve data if you don't want to use an external software. The unit is well protected over current, over voltage and over temperature. Alright, so this is Kickstart, the application for the power supply, and of course the application has discovered in my network the 2281S power supply, so I select it and I turn it on. And what happens is basically that the unit is remotely controlled now by this software application, which is very flexible. Here is where you can set the voltage level, the limit of current, but very interesting is the sourcing mode. You can actually upload a list of voltage, like a stir of voltage, if you want to perform some sequencing tests. So this is really a programmable power supply, and you can do basically whatever you want. Also, you can set the slew rate, you can apply some delays, and of course you can control the triggering machine in several ways. You have full control of the memory, and once you are happy with your settings, let's place 8 volts here for instance, you can decide to turn the unit on, which is done by pressing this circle, and then you are actually now searching 8 volts and while measuring and sensing the current. And all these data are, of course, continuously recorded, as you can see here, but much better you can see from the table of measurements, which also includes some statistics that you can set. You can go into the graph mode and you can see live how the graph is updated. And all these interesting things, they can be easily saved and mostly exported in a CSV mode, in an Excel mode, including the test configuration, including a very high resolution images and graphs with different backgrounds. And you can do this even automatically by exporting continuously your runs of measurements into a pre-decided path, a folder where you collect all your data. So what do I like the most about the 2281S-20-6 power supply? I like the fact that I have a really 120 watt DC power supply, programmable. I like the accuracy and the measurement resolution, which is quite important. I can go down to 10 nanoamps of resolution for the current, for instance. I like the fact that this is a very low noise DC power supply, very precise, so the ripple voltage is contained peak to peak in less than 10 millivolts. I like the transient response of this unit, never exceeding 50 microseconds. And I like, of course, the extra feature of being able to simulate a battery. And again, let me remember what simulating a battery means. It means simulating the voltage changes across time depending on the state of charge and the series resistance, the equivalent series resistance that goes with it. It means being able to upload a battery model into this unit, which you could have obtained in a different way from the battery supplier, for instance. The possibility to select not only the static battery simulation, but of course the dynamic battery simulation where the voltage changes depending on the state of charge. I like the fact that this DC precision power supply with the controllable output resistance can be used not only to test my PMU, for instance, or my design, but really as a flexible tool in production. I like the fact that there is a software application which you can use to remotely control this unit and to program the trigger machine. I like the fact that I can set a 4-wire sense connection for this unit and the possibility to detect open leads connection. I like the fact that I can upload voltage profiles so that the unit can reproduce like a sequencing mode, or the fact that I can program the unit using Skippy commands and write my own script to control the behavior of the unit. So this is it for today. See you in the next video. Bye.